All right. Good morning. Let's go a little bit higher. Okay. I am on the carpet. There we go. Yeah. I am starting it up earlier than usual this morning, so I don't know if we'll have folks around. It's totally cool if not, and if people want to catch the VOD, that's cool. If I'm just here working alone, that's also cool. Let's go to here. All right. So I will say, first of all, welcome. Thanks for watching. For anyone who catches this, if you don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. I usually stream actually a little later than this on Saturdays at 10 a.m. Central Time here on my channel, working on stuff related to CircuitPython. And I am just here a bit earlier this week because I was ready to go and figured I would get started. Maybe do some more stuff after the stream as well. We got a nice day and there's a couple of things around town to go and do, so I figured I'd push it up a bit. But I do usually stream around 10 a.m. Central Time, so about 45 minutes from now is usually when I start, and I work on stuff related to CircuitPython. If you don't know what it is, you can learn more about it at the main website, circuitpython.org. It is basically a version of Python that runs on these tiny computers called microcontrollers. The way it works with CircuitPython is typically, most typically at least, you will plug it into your computer with a USB cable. It's going to show up like a thumb drive. You can edit a Python code file on that drive, and when you save it, the microcontroller is going to execute and interpret that Python code for you. CircuitPython is primarily funded by Adafruit. They pay a team of folks, including myself, to work on the project. So if you would like to help support CircuitPython, as well as lots of other open source work that they pay people to do, one of the easiest ways to do it is purchase hardware from them, which you can do on their website here, adafruit.com. Looks like the new white LEDs are popping in as the new products this week. I've been hearing about these, but I haven't had a chance to see them yet. So these are like kind of like a NeoPixel in a way, but instead of RGB, the three elements of it are three different temperatures of white light. So there's kind of like a hot white light and a cool white light, and I guess maybe a pure white light or something. I don't know how they work exactly. But that's the idea of those. You can find those as well as microcontrollers, like the ones that run CircuitPython, as well as lots of other stuff over on their website. Jumping in where I'm looking at today, I will also mention that CircuitPython is a fork of a thing called MicroPython. This, right? If not, then we'll go to CircuitPython and click through. Yeah, here we go. So CircuitPython is a fork of MicroPython. MicroPython is similar in that it is a Python interpreter that runs on microcontrollers, but it is also different in that it does not do the USB drive thing automatically. So MicroPython devices, some of them can show up as thumb drives, but not all of them do, and it's not the primary way to program them like it is with CircuitPython. There are other differences as well, but that is one of the main ones. But CircuitPython is built on top of MicroPython. It is a fork of it. We try to merge the upstream stuff fairly regularly as well, so we're usually not more than one or two releases behind MicroPython. So we're always getting the new stuff as well, although some stuff is disabled in CircuitPython land, depending on what it is. What I am working with today is this Ting FX microphone device. So this is a device that this company, Teenage Engineering, sells. It is primarily, as I understand it, intended to actually go with one of their other things. I don't even know. What is that? Is that a record player? I don't even know what that is. Yeah, it must be. I think it's supposed to go with something like this. They make lots of different music toys. So the record player up there makes sense for music stuff. They have like samplers and sequencers, and so this is a sampler composer thing here, which is kind of like a little widget for making music. It's got outputs, I presume, for audio and inputs for audio, and you can dial up different effects and do all kinds of different stuff, and it will output. And then they sell this microphone as sort of like an add-on to one of these kind of things. So I have not messed with any of these bigger things. I don't know what's going on with those all the way, but the microphone I do have, and I am most interested in it more immediately. And what I know so far about the microphone is that it does use a RP2350 inside. I have some pictures of it. In fact, I'll open the... I don't know if I... Yeah, I don't think I should have done before I put it back together maybe was take a complete picture of the back. But yeah, RP2350 is the main brain of this device. So I have some pictures of the inside of it. I have put it back partially together for now, and I have it plugged in. I don't have the camera, so I can't show you the live one here, but there's not... my intention is likely to be spending more time on the screen than the device, so we'll see. I don't know that there's going to be much to see, so I didn't set up the camera. But this runs an RP2350, and it also, if we make our way right the way to the bottom of here, even maybe we need to go over here to software licenses, what we will find in the software licenses is that this is actually using MicroPython as well. And you can also tell this because we connect to it via serial. We can see that it prints the MicroPython banner. And in fact, it also is some kind of customized MicroPython that is printing this EP2350-1008, which is the firmware for their device. EP2350 is, I guess, sort of like a model number, they call it. Doesn't actually say that on the outside of the thing, as far as I can tell. The outside of the thing calls it Ting FX, this right here. But EP2350, it's referred to in other places. And so what I would like to do ultimately is put CircuitPython on it. And be able to use the hardware, importantly, because we could probably, potentially, we could just dump CircuitPython on it and it would, like, maybe boot up. But I want to be able to have CircuitPython on it, and I would like to be able to use all the hardware. So this thing has got 2 banks of 4 LEDs. It has got 3 buttons on the side. It has got the main sort of paddle button right here. Which is actually a sneaky 2-button situation. I should also say I just jumped straight in, and I meant to do a little bit of this, but I also don't want to just bloviate too much here about it before I actually start working. But I should say, in informal CC, this person, I'm assuming this is the same person who made the video. And I'm assuming this is the same video I watched. Yeah, okay. So shout out to this person, Hug Report, so to speak. They did a teardown of this. I think they're more on the product design, or call it like basically like product design type person. Or mechanical design. They're more interested in breaking down the parts and pieces of the physical thing. So they have this YouTube video. I encourage you to check it out. Informal Teenage Engineering Ting FX EP2350 teardown. They actually also tear down one of the big ones, one of these bigger sampler doohickey things. So if you're interested in one of those, you want to see the guts of that, this person also has you covered over on YouTube. So check that out. But one of the things that they reveal in their video, which you could also see partially maybe in some of these photos that I have, at least half of it, is this paddle button. It's actually 2 buttons. So there's one button here that when you first press in the paddle, you're actually releasing this little button here. So this is normally pressed by the paddle, which is forced outward by a spring mechanism that is inside of the lever there. And you can see what that is all about inside this video. This person does a great job I'm explaining it and showing it. And I mean, it's not like, you know, it's 8 minutes long. It's not like every single angle you could ever, but it was enough for me to get it apart and get it back together, for which I am grateful, because there is a little springy thing that kind of snaps on you and you got to figure out how to get it back. It's basically, it counterlevers on this thing right in here. In fact, there's the arm of a spring is butt up against this little plastic tab. So that's kind of like retaining this arm of the spring, which is actually forcing this paddle button outwards. Okay, and then that, when it is forced outwards, it's pushing on this button right here. So this button is normally getting pushed. You push the paddle, you then release this, and what we can't see from this side, but what we could maybe see from the bottom side if I had taken better pictures and copied them over to the computer. I got to see if I did get a good picture of it. I'm not sure if I did, but I didn't copy it either way. But what you can see in this video is when you flip it to the back side, there is actually a second button in there. So when you press that paddle all the way in, you're pressing that second button as well. So when you first start moving it in, you release a button. And when you hit the apex of it and get it all the way in, then you are pressing another button. So we've got those 2 buttons plus the 3 on the side, the 8 LEDs. The other hardware that's on this thing is, of course, a microphone, because that's its intended purpose. And then it's got a 3.5 millimeter jack wire that hangs off, so you can plug that into an audio device. What else is there? There's a potentiometer for volume. There's an accelerometer because you can shake it and do stuff with it. I think that's about it. Yeah, I think that's about it. But in order to like have ultimately the goal here, which is run CircuitPython on it and be able to use all that hardware, we need to figure out a bunch of stuff about it, like where is all those things connected? And I have kind of tried to start with the most challenging one, because I'm assuming the buttons and the LEDs, maybe the potentiometer, I'm assuming those kinds of things are going to be relatively easy to figure out. But the audio, I think, is kind of one of the more tricky bits. So I have done a little bit of digging inside, and I have found a good picture of that chip. I have found that this is the little ride-along chip that is next to the RP2350. So in this one, it's cut off, but up here is the 2350. This is the little ride-along chip. This is, I believe, what is kind of the audio brain of it. It's a codec chip. I plugged this into the internet and was able to pull up a data sheet for it. And it takes input from the microphone. It gives output, I believe, over I2S. It connects with I2C as well, and it can do a bunch of audio processing on board. I don't know 100% of its capabilities just yet, but that's what I know about it so far. And ultimately, it's going to be interfacing with this RP2350, and I want to figure out how. I actually started working on this yesterday, so I'll show you what I have found thus far, which is in here. In mapping findings. And to do this, I actually just sicked the old chatbot, in my case Opus, on it, and I gave it the firmware UF2 file. I had the device plugged in, and I kind of set it up with like what I was looking for was these pins and stuff, and it took a bunch of different avenues to try to arrive at it. It did some static analysis of the binary. It did some active sort of connect to the REPL, run some MicroPython code to see what different stuff is and what it was doing. It did crash the device a couple of times, but in the end, it came up with this guess as to what the pins are. And where I'm at, finally getting around to where I will start shutting up and working, I need to basically validate this, and the next thing to do is going to be to try to load stock MicroPython on it and see if we can run like an I2C bus scan and see if we can see the codec chip. And also, I guess we theoretically should see the accelerometer as well, which I assume is connected that way too. But slight hesitation before I do it, because it's not a stock thing. Not a stock MicroPython thing. So the device, when you're in normal mode, it connects as this Ting disk device right here. I should take a copy of this. I don't think I've copied this anywhere just yet. This one I think I did, but so in this case, the MicroPython device does actually connect as a storage drive. However, the storage drive is like the secondary sort of storage. I'll refer to it as secondary. It does not contain the main.py, which is the one that runs when MicroPython boots up by default. What it contains is you can put WAV files and you can put a JSON config file which configures the behavior of the microphone. You can set up different effects and stuff to modify the audio, which is very cool, but I would like the ability to do it all in CircuitPython, not just rely on the config file and the closed source like frozen module or whatever they've built in to do it. So cool stuff, but not the way that I want to play with it myself. But there is another sort of storage section as well. So we're connected to the REPL over here, and if I go import OS, lister, we can see there's ROM and FAT. And if we go ROM, we see main and another README file. And if we go FAT, then we see that stuff that we just saw in the Ting disk. There is this also, but there's these two files are the main thing there. So it's kind of split in this ROM and FAT, and I want to say that README in that README over there is actually the same, or is actually a thing that I already grabbed. There's ROM main. It was Ting disk README. Maybe I didn't actually. I think that it might be the same content, but I should actually take another copy of it. So let's grab that, or not another copy because I don't have. Well, I have. If it's the same content, then I have a copy. If it's not, are we like? Why is on the old preview? Okay, that's good. Let's get a copy of this. And so one thing about this device that's a little weird that I've found is there's MicroPython tools like AMPY. There's a thing called MP Remote. I imagine there are more of these things, but they are broadly tools that let you interact with a MicroPython device, typically over serial, over the REPL, just like I'm doing here in my terminal. But they facilitate you like copying files on and off, or listing files, or running stuff, or doing other things. This device doesn't seem very happy to use them, I've found. This firmware, I should say. Whenever you run commands through MP Remote or AMPy, oh, ROM. I think this is going to be basically the same stuff. It totally is. I don't know why they did a PDF in one spot and a Markdown in one spot. This is the ROM readme MD. Which, again, I do think is largely the same as one of the other ones that I've already copied, but just because we have a chance of potentially wiping the flash or other stuff going wrong, I think it's good to take a copy of everything I can at this point. So yeah, so it connects as Ting disk, and then when you're in the bootloader, so right now it's Ting disk, it's in so sort of quote unquote normal mode. So to get to the bootloader, you hold the paddle, and there is also a little reset button that is near the USB port. Ooh. One more screw back. So with lots of MicroPython devices, the way that it would work is you would hold the boot button while it boots up, while it turns on, which usually means you would hold the boot button and then press the reset button, and it would boot up into the bootloader, which would be like RP2350. Oh, I don't think I got two. So this one is different. There we go. Finally got it. This one is different. So what you need to do is you hold the paddle button on the side, and you double press the reset button, which is underneath this panel right here that says Ting FX. I think there's a picture somewhere. Right here they show double click. So you hold the paddle, you double click this thing, and then they say this drive called either Ting space boot or RP2350 will appear. So RP2350, this would be the normal thing. This is what you would see on a standard RP2350. And so this tells us, and in fact, this is what connects to mine. This tells us they have for sure like modified the bootloader. Let's do a cartoon. So I don't know if it's going to let us install MicroPython, so this could be anticlimactic. Because it's possible that their bootloader, like, first of all, there's a thing in Raspberry Pi where you can like lock it, basically lock the ROM or whatever. I don't know the right terminology for it, but basically they can set a fuse in it. They can flip a switch when they first flash it that says like you're not allowed to flash it unless the thing is signed. And I can't sign it with their key because I don't have their key, obviously. So in that case, I would not be able to just flash whatever firmware I want. Which has a consequence, like this says, means Pico tool can't be used. Machine. Trying to get to machine. You know, I thought I found a replacement for machine. I'm going to poke around a little bit more in the MicroPython that is there before I make the leap to trying to load stock. Because, so, as that thing notes, there is no machine, which is, I think, as I understand it, odd for MicroPython. Usually there would be a machine. I think there might be... are like strings? String stuff. Oh, I tested a string, I guess, and that's not how that works. It may... Is there anything... A compiler? What does that mean? Okay. Thing. Lib. I wonder if that could be talking about the teenage engineering lib, or if that's talking about MicroPython lib only, maybe? Because the other thing there is teenage has their stuff. I really thought there was also still a way. So teenage, I think FX, and I think maybe UI are all custom things that don't normally exist in MicroPython. I was... thought there was something that I found that was sort of analogous to machine. One thing I'm curious about is the size. Does this report a size? I don't know if that would be accurate. One question I have, though, is the flash chip. If there is a QSpy flash chip, I don't know which chip it is, or if I need to do, like, anything special for it. Hmm. SPL might be a custom one too, I guess. UI, I think maybe has stuff for the lights. Oh, it actually has everything. I don't know how it works though. That did not actually change anything. Oh, interesting. That one did for sure. So now there's 4 whites and 4 reds. Right now there's doing that made it so that 4 whites turn on and 2 of the reds turn on. One of the white ones turned off, another one of the white ones turned off. One. Would you do all off then? Interesting. Oops. Maybe -1? 4. -1. All right, so then so UI LEDs -1. So the first argument is the red LEDs, and the second argument is the white LEDs. And whichever, you can't control them independently. It seems like it's like a meter basically. So you give it an index, and it turns on all the LEDs up to that index, inclusive. So when you give it 0, the first one comes on. When you give it 1, the first 2 come on, so on and so forth. That's how that thing works currently. So that is good to know. That possibly, because that could be a hardware thing. That could be like, we don't actually just have LEDs on 1 per pin or something. We could have some kind of module that is getting signals that are telling it to count up like that. Yeah. So this is the part that I'm a little weary of, which we're gonna take the plunge and do it here in a minute anyway, but basically, because it has a custom bootloader, it means it doesn't show up in PicoTool, which means we can't do a couple of things that would be nice to be able to do. One of which is checking the secure boot thing, so we could know before we dump a UF2 on it whether it's likely to work or not, which would be nice. But the other thing PicoTool could potentially do is help us recover in the event that we drop a UF2 on it and it doesn't stop us from doing it, and then it is like soft bricked. See, I don't know. So I will say this was all written by the chatbot. I don't know that this is true. So the Ting bootloader may well accept the MicroPython file. It confirms the 2350 ROM boot cell is reachable. USB is wired to the ROM. Yeah, I don't even know what that means really. USB is wired to the ROM. Doesn't really make any sense to me. Should we aim for, I will say that's talking about using 128. But I do notice the one that's on it now is 126. Yeah. So here's our foreseen potential outcomes. We drop MicroPython UF2 on there. It just tells us no or doesn't work. It goes back to being the same thing it is now. It accepts it and it boots up and we're in MicroPython, and that's good. That's the happy path. And then the saddest path. I mean, the first path is kind of sad because that basically means we can't really do what we want. I don't think they would have locked it, but I don't know. We'll see when we try. The saddest path is it lets us drop the MicroPython UF2. It flashes itself with it, and then it doesn't work anymore. We can't get back to the boot drive. We can't get back to the REPL. We can't get back to the doing anything. And what the chatbot here says we would need to do in that case I might ask it. I got a picture of a thing that might be the crystal. I'm not sure if it is. So then here, so flash. Already opened. Opened? Do not attempt the reflash until you're prepared with the hardware recovery. So this is part of why I'm waffling here, is like I don't think I am really. You could, i.e. you could briefly ground the QSpy flash at power up to force it into ROM. You'd only T4. I think this that it's talking about is not flashing MicroPython. I think it was talking about doing more analysis inside of its own flavor of MicroPython. And then it wrote a script that will do a scan. Restore when it's done. If MicroPython is running, then we can go machine bootloader, and that would get us back to the bootloader where we could flash back to the actual Teenage Engineering firmware. We could use Pico tool at that point as well. But I don't know, does MicroPython come with the bootloader? I guess maybe. Okay, so it says recovery only needed if the reflash left it with no working firmware and no way into a bootloader. Momentarily ground the chip select pin while applying power. With no readable image, the ROM falls through to USB boot and it will present as the RP2350 drive. Release the chip select and then restore the firmware. Reading only T4 probes. Okay, it's referencing the other file. We could maybe push farther in the teenage engineering firmware. Like, I could stop it from running, potentially. Because, like, it has MainPy. I could change MainPy to just print hello or something and not do the teenage engineering stuff. Then it would presumably not start up the bus and do all the stuff. Because, yeah, one of the things that I found while doing this is that if it tried to get a little too aggressively doing stuff on the I2C bus, the device seems to just lock up. T4, staying on the TE firmware, no reflash. Rerun the passive dumps. The active probe must quiesce. Must first quiesce the firmware's audio in an XL loop. Not obviously possible from the REPL. One thing it might be interesting to explore is, I don't know what they mean quiesce the loop, but could we not just make it so it's not doing that and then go on and do our own thing? I mean, it is odd though, like since it doesn't have machine, that means it doesn't have pin. But I thought I found a pins thing somewhere else. MicroPython. Machine? I thought there were GP. I don't know. I thought that I had found something in one of the modules that made me think that it was sort of analogous to machine. I don't know where I found. Okay. I think we try this. Look if there's a 126, and if so, how old it is. DEL 12.0. Capacitor by 8. In this case, it's cleanly mapped. You could actually trace the pin if you wanted. So one of my other, so obviously this recovery path is all talking about using the chip select pin of the flash chip. And I'm not certain which chip is the flash chip just yet. I have a guess, but I don't know if it's correct. So on the top side of the board, there's really only 3 chips. There is the Pi. This, I think, is hopefully likely the crystal, with its 12.0 being the 12 megahertz or whatever the default thing the Raspberry Pi wants, which was another thing that this was warning about, right? Frequency, this assumes a 12 megahertz thing. If it differs, then expect outcome 3, verify before. But obviously I don't have the schematic. I don't have the bill of materials. I can't do that. I can see this picture of this thing, which has a 12.0, so it seems plausible that it is. And I will say that thing does look like a similar sort of object as this thing. I don't do a lot of PC sort of like, I don't do a lot of this chip recognition stuff, so I'm still fairly new to it. The Raspberry Pi is easy. It has a logo. If only they would all do that. Sort of looks similar to this thing, though. And then flash chips, in my experience, I've seen them usually with 8 pins, right? 4 and 4, so I was also asking about flash chips to the chatbot earlier with this picture, which is a chip I found on the back, though. So it's like it's a little bit more difficult to get to. Because you gotta take that board out. There's a couple screws. You gotta flip it over. There's some thin wires you don't want to break. But on the back is these 2 chips. These are basically the only real things on the back, chip-wise. The LED stuff's back here. This is really the only chip that's 4 and 4 as far as the pins go. 4 pins on each side. So one of the things that the chatbot was telling me, so pins would go starting with the dot to 1, down this way, 1, 2, 3, 4, 5, 6, 7, 8. That 8 would be frequently near a capacitor. I think it said capacitor, maybe it was resistor. We say it was a passive component. I could look back in the cloud session if we wanted, but I do notice that that is definitely the case for this one on this Pico here. Right next to pin 8, there is a passive little thing. And then on the TE, there's this, and maybe that connects, but it's not exactly 100% confirmed from this photo, I wouldn't say. But it's also trickier because this is on the back, so a lot of these end up just going, right, there's like a million vias around it that flip it through. And then the RP2350 is like kind of somewhere right in here on the other side of this, so it's difficult to say like what it could be connecting to without a very, very thorough dig through. So there is 26.1.0 and then 28, which is what it decided I should use. So yeah, I mean, it got all this, like, it kind of went down this road of, hooray, everything's going to be fine, based only on the fact that, Like, I think, at least, based only on the fact that this says the drive could be either one of these. Another thing that I have noticed is my device was actually on 104 when I received it, which is not listed here. 105 is the first one listed here. All right. We've stalled for as long as we can. Let's give it a try. I've been using a rubber band to hold, because you have to hold the paddle the entire time that you're in the boot drive. Makes it a little bit difficult, actually, to copy files. I rubber banded it, and then itself in. I still do find it challenging to get the double click just right, though. We got it that time. Yeah, there it is. Okay. Fingers crossed. Let's hope we don't break it. I think I'm like fairly tempted to just use MicroPython 125. Sort of tempted to just use the one that was on it. I don't know that it matters, but all right. I think that's a thing my OS does sometimes, so anticlimactic, but I don't think that's actually real. Does this with CircuitPython as well for me sometimes, where it's like my file manager here will tell me you don't have permission to paste that. It's going to want to quote. It put the slash at the end. All right, copied, disconnected. It's not reconnected here. Okay. Okay. It's not gone. Has machine. Okay. I already feel a little better. Let's undo the rubber band. Did we undo the rubber band? Is that a terrible idea? Let's keep the rubber band for a minute. Let's make sure bootloader works, honestly. That should probably be the first thing we do, is try that, because that's going to be how we get back out of this. And there's a chance that that's going to require the paddle to be pressed in? Question mark? I don't know if that's true or not, but disconnected from serial. Reconnected as Ting boot. Okay. Okay. What do I want to do from there? So Interestingly, we came back to Ting boot. Which means we can't use EcoTool, I believe. I'm going to press the reset button once, which is presumably going to take us back to non-Ting boot, what is now stock MicroPython, which will not connect as a drive, but should be back here. Scrolled to Narnia in this thing. Okay. Firmware testing, let's do the test that we needed, which was I2C scan. Doesn't know which one is which, so it tried both. Or if I could use Ampy now. So one of the things I was finding with the teenage engineering firmware that comes on it, when I would try to use Ampy commands, it would just get locked up basically. One question might be when we get back to teenage engineering, did we wipe those two, I'll call them partitions for lack of a better term, but those two portions of storage? I don't know. So it feels like this is succeeding in that there just are no files. Can I put a file or folder and its contents on the board? All right. Let me check a few more things before we get too far down that road, just to clarify some stuff with bootloader. So I can get back to bootloader with machine.bootloader currently. Currently, the paddle is still rubber banded down. We're still running MicroPython. I'm going to unrubber band the paddle. Disconnected. Interesting. Okay. Not connected at all. Let me push the paddle. I will say in teenage engineering mode, you push the paddle to sort of like wake it up. Oh boy. Sting. Okay. So you legit have to hold the paddle in. It turns off. And you release the paddle. Fascinating. So there is built-in... I keep going back to it, thinking it's the other one. There is built-in, like, sleep logic, although it's mostly for batteries, I thought. When it's powered over USB-C, it will stay powered until you pull the cable. This is in standard firmware mode. But here's the bit that I think is interesting. 5 minutes after releasing the handle, it'll go into power saving mode. 20 minutes after releasing the handle, it will turn off. So there's like some higher level of control. And I am starting to suspect, so I have a picture of one other chip. This chip is also on the front with the RP2350 and with the audio codec chip. I don't know what it is, but it could be power related. It sits physically between the RP2350 and the USB port, which would make it convenient for doing stuff with the power coming in from the USB before it gets to the RP2350. It could be the case that that secondary button in the paddle is also connected to this, and this thing can, like, cut the power. Although, I don't know why it would have these timers. If it circumvents the 2350, and if this thing is in control of the power and is able to do its own countdown and everything, well, two things. It's supposed to just stay on when it's plugged in with USB, which it is currently. And then the other thing is, I don't know why we would get different behavior now, because we're not getting 5 minutes. We are getting, as soon as I release the handle, they call it a handle, not a paddle. As soon as I release the handle, it powers down. And it's like no longer connected. No, I mean, there was no drive anyway, but no serial, which is how we know it was connected. Yeah, interesting. So I will put the rubber band back. I'll run the I2C test. What's the paddle situation mean for us long term, though? I mean, well, presumably there's something in their version of MicroPython that is making it stay alive longer. All right, paddle is pressed back in. And this is even just connected already. I should have done a little more press and unpress before I rubber banded it, but all right. I2C scan on pins 14 and 15. Might go make another coffee. One thing that starting early did was throw my coffee situation off because I was like a little bit under halfway through. I had more than I wanted to just slam right away to make a new cup, but less than enough to get me through the full stream. Ampy, so that it would be P. Put main pot. Okay. I mean, good news and weird news. The good news is we found what we expected, which is the accelerometer at address 18 hex and the codec, which is the audio chip, at address 1B. Weird news. Oh, okay, okay. Never mind. Whew. I thought this was switching the pins around, right? Because, like, this is pin 15, this is pin 15. Patty corner. 14 on the left, 14 on the right. I thought they were switching around, but they're not. SDA 14, SDA 14. SCL 15, SCL 15. The actual difference is this. Soft I2C, I2C. I don't know why I bothered with that, honestly. But that's fine. So good news. Good news is we found both. We found the accelerometer and we found the codec. Best promotion on no. I don't need that. Thank you. Do I really believe thank you? I don't, but I'm a nice person, so I will say thank you. But also, you are henceforth banned from my Twitch for joining us. Okay. So we got I2C. We have a guess. JP says, nice. What's up, JP? Nice to see you this morning. We have a guess on the other pins, I2S pins as well. I wonder if we can try to validate the rest of them. Yeah, it's tough to decide which direction to go. So I could start to try to work on I2S. We have the I2C pins nailed down. If we get the I2S pins, then theoretically we could start making sound come out, which would be cool. Get your bot components at adafruit.it. Adafruit.it. What's up, Tithe? Nice to see you, my friend. That would be cool to get audio coming out. Another avenue we could chase further is this power situation, though, because the handle having to be plugged in, or the handle having to be pushed in order to keep MicroPython alive. Puts a damper on what we want to do with it ultimately, right? Like, but we do always know that there is some magic sauce that will do it, right? Like in the Teenage Engineering firmware, there's something in there that is making it be able to stay alive. We should be able to figure out what that is later and put it into the firmware we want, hopefully. Let's try to chase I2S a little bit. What I'm going to do is actually move this. So currently it's plugged into my computer. I've been doing this all from my computer here so far here on the stream, but I'm actually going to unplug it. I'm going to plug it in over here where you all cannot see. Which is this device. Yeah, it doesn't connect as a drive. Okay, yeah. So now, this is a Raspberry Pi. This is a Raspberry Pi where my helpful chatbot friend Claude Code runs, and I think we could maybe have it poke around a little more. So why don't we tell it this? Please read pin mapping findings.md and firmware testing instructions. Read that? I don't know if we need to read that one, actually. Let's just do this. Please read pin mapping findings. Get up to speed. I have loaded stock MicroPython on the Ting FX device, and it is connected at dev. I don't know why that suggested exit for me. Why ACM 0, I'm going to assume. Hopefully that's the case. It's connected at this. It's, let's say it's REPL is. I have confirmed with the I2C scan code that the I2C pins are in fact. Well, let's just say I validated. With IC, I have validated with the I2C scan code that the I2C pins in the findings file are correct. Can you please work on validating the I2S pin? They should be connected to the what is up, C. Grover? Nice to see you, my friend. It should be connected to the NA. What's this thing called? NAU 88L21. NAU 88L21. Codec. Chip. There's a data sheet for it in this directory. See where that goes. I am going to start working towards a coffee, so I'll be right back. I'm going to put the kettle on and start moving in that direction, but I'll come back before I have it. Okay, this command reply, yeah, that's cool. So yeah, a lot of what I found yesterday, I found with Claude's help, and it did a lot of static analysis of the firmware. I gave it the UF2 file, the Teenage Engineering one. It was picking that apart, even with just basic tools. I didn't give it like Ghidra or anything advanced, really, decompilers, deassemblers, or anything. It was working mostly with stock Raspberry Pi OS. I loaded like PySerial and one or two other Python libraries, but with whatever stuff was loaded on stock Pi OS, it was like dumping bytes out of the firmware to try to confirm stuff about the pins. So this is gonna send Control C type stuff, I think. From the firmware. Running machine uname prints and similar. Would be interesting to see if we could get back to the plain RP2350 bootloader instead of the Ting boot thing that would allow us to use Pico Tool. Could the bootloader have something to do with the power? I mean, no, not really, right? Because we're on, I mean, we're still on their bootloader, presumably, because we have, so machine and RP2. So RP2 was on the Teenage Engineering one. It's giving itself a little checklist. So it will try to find it on the I2C bus first and see if it can read the ID for it. I don't know how it's going to plan on validating the other pins. So eventually what I could do is feed it audio back. So the microphone outputs with a 3.5mm jack, right? I do have a, I don't know, it's probably not going to come through on the camera very well. I have a little USB audio thing here that I could plug into the Pi and then plug the microphone into it, and then it shows up as an audio device. It could save audio from it. Uh-oh. It's that Pi PDF. That's weird because I thought yesterday it did. PDF to text. Maybe that's what it used instead of Pi PDF. I could give it Pi PDF. Okay. I heard the kettle. I'm going to go and start up that BRB. Okay, roasted bean potion is going. was talking about that 0x58 again, which I think is what it said. No, that was 54. I don't know what 58 would be. Device ID. Oh, that's a register address. Sure. E23. One codec identified. Register 58 holds 1B23, matching the Silicon Revision default pattern. Only the live mic det status bit differs. Study the datasheet's clocking I2C loopback to design the pin validation. An 823. We're probably not going to find that. We are. 823. Device ID, register 58. It's 5 to 2. 1823. 2020 revision. That's the only place. What is, what else can we find about register 58? Change, actually. Not a register? Whole register. There is a whole register map. Why does it not use the word register map anywhere? This isn't stuck. Yeah, so one thing is this audio chip seems quite complex. It seems like it can do a lot. I don't know what all of it is being used. There we go, control and status registers. Oh wow, I've never seen one like this. That's interesting. Okay, how do we read this? Where's the address? Okay, so addresses are over here. And so 50, what was it? 56, 58, 58, I think. Eight, I2C device ID. Stuck. Master mode B clock can be. All right. Device ID. So then. What are the grays? I should have read the legend before I got to here. What page is this? This is page 65. What do the grays mean? Is that default or reserved? Maybe? There's no legend. Right? Any value wants to reset all the registers. Oh, okay. No. They're not reserved. They're indicating which bit it is. The default is down here. Okay. So this is saying that clock. So this is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Seems like a weird amount, but this is a 13-bit register, or maybe it's a 16-bit register. It's only using 13 of them. Yeah, that's the case actually, because there's 2 blanks here and there's a 3rd blank here to get down from 16 to 13. So 16-bit register, this bit here, the far right bit, least most significant, is the clock DRC enable. And the 3rd one here, we skip one and then we go to here. This is the OTP, and then so on and so on and so on. So these are highlighting which bit that row is talking about. So the device ID is this whole thing here. It's 7 bits all read together. And in order to know the default, we would actually have to convert this back from hex. And I don't know what the X would mean. I wrote some code to try to discern one of the clock pins. M clock. detect, so there's the mic detect it was talking about. Oh, mic detect, as in there's a microphone connected, which is true in this case because there is a microphone detected, well, connected. So default would have been 0 when there's no microphone, and I think what this thing set up here is that it was 1, presumably indicating that there is. Oh, hey, we got a major find in there. That's cool. Oh. I mean, there's no saying if this was a hallucination or not, but at least back here a couple of turns ago, it's saying the pins are clear. What is up, my friend, over on YouTube? Andyman4. Nice to see you, my friend. Thanks for checking out the stream. You know, if you have questions or anything. Let's see, what do we have here? So, frequency counter. Bit 5 is stuck at missing in all states. That latch detector needs internal clocking I haven't set up. It isn't clearing cleanly. Rather than rabbit hole, finicky status bit, I'll pivot to the decisive direct method. Put the codec in master mode so it generates that from mclock, then measure the frequencies and watch them stop when I remove mclock. First, let's build and validate PIO frequency counter. Can you use PIO code? We'll see how far down the rabbit hole it gets. We're up to 92K. I try to keep my sessions like, I mean, 200 is like, that's what the old limit was, if memory serves. 200 or 250, one of the two. I think it was 200. I tend to try to stay under that if I can, both because I feel like it works better when the context is smaller and because it starts to chunk up your usage much, much, much faster as your context gets bigger. And one thing I will say is yesterday while I was having it do some of this, it's very eager to continue exploring and validating and reverse engineering At one point, I had to basically like it asked me for permission to do a thing, and I was like, we're pretty long ways into this. We were pushing around 150, 160 or whatever context, and I was kind of just like, all right, okay, yes, you can do that, but also try to wrap it up pretty soon. And get what I like to do is get it to write out its write out like a take home thing, right? Like a findings or a conclusion or a just something actionable. Just get the essence of the session written down into a markdown file, to then pick up with another session if we want, or for me to read over and edit and then pick up with another session if we want, is another pretty useful way to do it. So we'll see. We're at 92 now. If it dives way too deep on just the first one of these pins, then I may end up telling it to write what it's found so far and give a nice little bow on it for a future session. How could the paddle work with the power thing? That's so bizarre that the power... It's like the power just dies as soon as... Oh, hey. One of the red LEDs is on. That's interesting. Like the power just dies as soon as I release the paddle. So what could they be doing in the MicroPython firmware that could negate that somehow? It'd be some kind of watchdog type thing, like MicroPython has to feed the power chip somehow? But then how would that be connected? Because it's not over I2C. Maybe MicroPython, maybe there's an I/O pin that's tied to an input on the power chip. MicroPython has to immediately drive it one way or the other. Moved. Oh, we didn't really get any frequencies in there. For what it's expecting, honestly. Sounds a bit similar to Arduino Nassau N1, which had a battery management, power management integrated controller, had a low watchdog reset limit by default, or its support package in the default firmware bumps that up to 30 seconds, as well as enabling a battery charger, which is off by default. I wonder if the little power management chip is a similar situation. Nesso. Interesting. Keyboard support, it would bump it to 30 seconds. No. Nesso N1. Interesting. They're externally held low. Tested fast sampling detector. Oh, interesting. This would have both data in and data out, possibly. I've not messed with a device that does both yet, and if you don't count this. Imagine they might have a chip with the two sleep states, or use the RP2 deep sleep internally for the 5-minute window. And then after 20, the power management chip goes ultra sleep and everything's killed until the GPIO attached resumes it. Yeah. One thing that would be interesting to see is, so I'm pretty sure you have to push all the way in order for the power. And it did say 5 minutes was sleep, well, to power saving. I'm pretty sure the way that you wake up from both of these, though, is just by pressing the paddle, like all the way to hit the second button. The red light's back off. I wonder if it accidentally found one of the LED pins instead of one of the codec pins. Because a minute or two ago, the one of the red LEDs was on. Oh, it turned a couple of them on right there. It was doing some kind of sweep thing. Eventually, we'll get to those as well. I figured that the codec is going to be the hardest thing to nail down. The LEDs and stuff. I mean, maybe it would make sense though to go back and do the LEDs anyway. If they're one per pin, that would knock 8 pins out of contention. Try a slightly more. I did try searching the markings on this chip, and I came up fairly empty. I got one guess from the chatbot that it might be power related, which is kind of what sent me on the maybe it is power. Try something like that. Do we get any? No. Problem here though is sometimes these chips, like whatever's written on there is just a date code or whatever, a batch number or something. It's not always a like model, basically. Not always the thing that tells you what chip it is. I am learning. Up to 121. Yeah, if we hit like 150, 160-ish, probably around there, one of the times when it asks me to do something, I'll push back and ask it to start wrapping it up. Getting some frequencies now, it looks like. It copied. Well, did it copy that code to it, or did it running that from this directory? Not from temp directory. Okay. Decisive result. Clock sail exactly with mclock on GP12. Ratios nail the identities. Mclock GP12. Clock 8 to GP, I don't know. Both perfectly linear. GP16 does nothing. B clock matches B clock div 1/8. FSLR clock 10 matches that. This corrects the findings on 2 counts. M clock is 12, not 16. B clock, L clock are swapped. Versus guess. Let me record progress. I wonder where it recorded progress. Oh, it's waiting. Wait, what is it waiting on? Oh, the dialogue, right. When you're in, this is one thing that's weirds me out about Cloud Code, honestly. When you, there's Control O, right? Control O opens stuff so you can see more stuff, but then it hides the dialogue that is like explicitly asking you for input as the user. Like, why would that be hidden when you're in more open mode? I don't understand that. But it is gonna what? Do some more PDFing. Okay. Well, what are we? Data? I'm tempted to just tell it no here to write its findings and to write a note about what it thinks needs to be done next. About this, yeah. Instead of trying to validate the D in, D out pins now, please write new file. U88L 21 pins dot markdown. Technically, it's got I2C pins, which also have the accelerometer, which we found and validated as part of this, I suppose. But like, I don't know. Mostly we're interested in the codec. Instead of trying to validate that, please write a new file that with the conclusions you've found so far, and also include the steps needed to carry on with the data pin tests in a future session. It's a little early, but I don't know. I'm unsure. Like it felt like it spent the most of its time on M clock, and then it kind of just got the B clock and the LR thing as a throw on there in the end. Check the image at Gemini 3.5 and hope. Yeah, I was a little surprised at how eager it was and how well it was able to do the static analysis stuff. Although I will say, like, the static analysis is what led to that pin 16, which we just found was wrong as well. So it's like perfect, but. All right, let me update the task list. Correct the stored pin map memory. That must be where it wrote it. Yeah, the thing is, like, Cloud Code is also keeping its own memories elsewhere in different files. I kind of try to get it to write markdown files in the directory I'm in, Makes it easy for me to review and go and change stuff and load up the next session. But it's also got this like out of band memory thing where it's saving it in its like .claude folder somewhere. TLDR corrected pin map. Written this, updated that. Here's what we got. What's validated is codex identity confirmed. CSB, I don't know. Chip select B, I don't know what that means. Device ID register, we got 1B23. I2S clocks proven by putting the codec in master mode, measuring the frequencies it generates. Okay. 2 corrections. What's deferred? Data pins. Those are strongly indicated. Pull tests. Showed this. GP9 held high. There are only 2 data pins left. In the markdown file, maybe, but not on the device. Yeah, I was doing bits when interrupted. That's fine. Okay, yeah, that's where we can get to next, is once we have all the pins nailed down, I think the next step is going to be to ask it to try to make some audio. I never redrove pin 16 destructively, but it did drive many candidate pins. That's fine, yeah, so pins are in a weird state, who knows, that's fine. Okay, cool. Let's take a very brief look over what it made here, and then start up a new one to find the data pins. Not fully proven. Yeah. I mean, I don't know. Maybe. Oh, actually. If this is not a hallucination, we may have just got like a 2 birds, 1 scone situation. Maybe pin 16 was driving at a frequency and that was helping the timing power situation happen. Maybe this is the magic that kept it alive. So theoretically, we could validate that in stock MicroPython by trying to drive that at a frequency and see if we can release the paddle and stay alive. Now, one question would be is like, does the frequency correlate with the time or something? And if so, how would we figure out the right thing? We'd have to, yeah, I don't know how we would figure that out. Okay. Food for thought, though. Definitely interesting to see. Okay, yeah, let's have that start up. I don't know if it will need to go back to the other markdown file. I'm also partially tempted to point it to the other one, the firmware, or what was the other one? Was the findings one. I think Scratchpad might have been in IMP. It might be in temp. One tricky thing is I don't know which one would be which, right? Presumably those are like sessions. Let's try this. So it's asking to like rewrite some new code or something. I'm just going to tell it no for now. I think the previous sessions scripts are in here. However, it looks like there are 2 sessions in there. I'm not sure which one was the direct previous session. I guess timestamps would tell us probably, right? I mean, theoretically, the hash should tell it too if I were to go find that somewhere, but still doesn't have those files, though, it looks like. They're under Scratchpad subdir. Let me copy them to my Scratchpad. I have noticed this before. Clyde Code sometimes does this, like, text is getting all jumbled. Uh-oh. Let me make sure it's still connected. Oh, died. Or did it? I think it's stuck. Yeah, it's not responding anymore. Maybe we found our 5-minute. Maybe there is still a timeout or something. And there's no more ACMs. I'm gonna try to reset this. Hopefully it's gonna come back. Okay. Oh, I need to exit out of that though. This is gonna try to do some more stuff, so it should just find it and be like, oh, it's back, hopefully. But that's one thing to maybe still try to figure out is like, is that a time thing? Like if I just left it running for 5 minutes without touching it, would it disappear at the end of 5 minutes in any way? And then actually after 20 minutes, I should do the same thing. But I mean, it's after you release, which we're never releasing, because right now it's rubber banded down. Uh-oh. Timing race in the helper? Wonder if it... say, I wonder if it timed out again. It's possible that it could do something that gets it in that locked up state. That was happening in the teenage engineering firmware a little bit. Was like it was doing stuff at the REPL, and that was like causing the device to lock up. And then somewhat amusingly, Claude was like, let me just wait for a second and then try again. And so then it would ask me with the next prompt to let it try again. And I would switch tabs over to the other tab and like reset the device and then verify it came back and stuff. And then go back and be like, okay, yeah, you could try again. And so then from the Claude sessions perspective, it's like, oh, the device just came back cleanly, no problem. And I'm like, well, I did reset it for you. Like cleanly per se, but DNA control register map. Yeah, this was another thing I found interesting. Is it's interrogating registers of the Pi itself in order to find out information about the pins that are connected, which I did not know that was a thing, really. Interesting. What is this? 23 megahertz sine wave generation. Look at that section. It could drive a known signal. That, well, 23 megahertz is awfully fast, I guess, for any kind of for the watchdog type situation. Maybe it would be the, I thought we found the clocks on the MM sign generator is on the dock headphone analog path, not useful for ADC out. Straightforward approach is EDN. EDIN is to enable the ADC, detect GP8 starts toggling. ADC free running noise dither in the I2S frame, gated by the M clock presence. Let me check up the task tracking. Baseline clean and informative. Both data pins are static. Clocks run. Looks like we really get any action on GP8. Enabled. GP8 stays to 0, the ADC digital block is on, but with the analog front end unpowered and no input, it outputs all 0 samples, so the data line idles low. Need to power the analog front end so the ADC digitizes the noise floor. It's going to go look in the datasheet again to find a way to power up the analog, whatever. Front end. There is, well, no, the other button wouldn't do it. With the Teenage Engineering firmware, one of the buttons plays a built-in sound effect. And I was thinking I could rubber band that button down so that it's just constantly playing. Then there would be data always, but... Well, I don't know if that would be output. I guess that would be output data. But I don't, does it output IOS? See, I'm a little unclear on how this is going to work because there's a microphone and there's an output. And I believe both are connected to the same codec chip. But presumably, obviously, the way that it needs to work is the input needs to go into MicroPython, get modified by some effects chain, and then get sent to the output. But both the microphone and the output are connected to the same codec. So it's almost like MicroPython got inserted into the middle of this thing that's actually all inside of one codec chip. So I wonder if we're going to be doing I2S in and out. Like, microphone is going to come into MicroPython through I2S in. It has the opportunity to do whatever it wants, i.e. effects chains. And then output goes back out I2S into the codec, which is wired to pass it through, in this case, to 3.5 millimeter. If it does follow this, but those don't. Huh. Interesting. Good positions. So it's talking about it's going to have a, there's some indication in the register maybe of the pin state. That data sheet. Wait, 18? 1D. All right, I'm going to go get my coffee. All right, so that thing didn't work. Use ADC out, always drive 0 when idle, goes high when no data. That affects only ADC dat, OE. If that's true, theoretically it's going to validate both at the same time. We are up to 90K again. Yeah, definitely a good thing that we stopped the session. Start a new data pin. Block off GP8 candidate, ADC out, drive. Pushes it low. Codec is actively driving it. Tri-state. Every codec state, it follows the MCU pull up. One, it's never forced by the codec, so it's not a codec output. Test 2 is proven. Now the positive direction test for 9. Task 3, actively drive it both ways. Confirm the MCU controls the actual pad. Reading the real pad off the SIO, GPIO in register, not the output latch, while the I2S is active. So theoretically, we now know both 8 and 9, but we don't know the direction of 9. But yeah, direction. Or is it still validating 9? All results clean, manually consistent. Both data pins are now positively validated. GP8 ADC out, codec output. It's going to update the file as well. ADC out, idle's low. This is like how it proved it, because it idles low, the MCU pull up, loses while the codec drivers are enabled, and wins only when the codec tri-state reads 1. Drive is gated by the codec's output. UP9 drives the real pad, drives, not derives, drives the real pad to both 0 and 1 with no contention. Codec never forces it. Pull up reads 1 in every state. Word pull up on the back in net explains the idle high. Confirmed. Both pins are now confirmed. I should have just said allow edits. Okay. So right now, this is connected to audio-wise to my computer. The USB port is still plugged into the Pi, which has Claude Code running, but the audio 3.5mm is actually connected to that USB adapter I showed you earlier, and that is connected to my computer. It is currently sending no audio. I believe if I talk, nothing will happen, right? Okay. And that's just because this is outputting nothing. Findings doc was updated, so it updated the findings as well, or just the pins. There's a file with findings in the name too. Nice. We do the final state. Sure. ADC disabled, no driven, all those released. Okay, I think I'll wrap it up before too long here, but I would like to try one more, is if we can see if we can get it to make sound. That's fine. 16 will be a target for another session. I would like to try to get some audio. I think it would be cool if we could get audio. How realistic of a goal that is, but and I probably won't go too far down this rabbit hole today right now. So we'll look for a quick win if it's like it's got the data sheet and stuff. If it's able to quickly just do something to get, I see a little blip back there. If it's able to just quickly do something and it works, then hooray. If we get too far into the weeds of we tried it, it's not working, we tried another thing, it's not working, we tried it, but like I'll probably skip for now. I'm gonna wrap it up before too long here, I think. I wonder, I should have asked it once to like convert the datasheet to text and then start using, because I think it's like redoing this PDF to text extraction every time. It might be, it might have saved tokens and time potentially to get that converted once and then keep reusing it. Drippy says, be nice. Josh Claude, hey, you doing anything weirdly inefficient right now? It's like, yeah, I can convert this PDF to text every time I look at it. Yeah, I do wish there was a little bit more ability to interrogate it, sort of like see what it's doing. Like I would almost argue so I've been doing Control O to expand. I would kind of like it if all of this was just default. It would show you. I mean, they're trying to keep it clean, I guess, but because you do as you read, if you actually read some of the stuff it's doing, sometimes you can definitely like. There's times where you catch it and it's like going off in a weird like direction, and sometimes the weird direction leads to a place that works out in the end and was not a thing you might have considered, but other times you're like, I don't know if this is necessary. There might be a much easier way to do this. All right, I am going to loop back. I do think this is kind of our next sort of potentially big hurdle here is like we've gotten plain MicroPython firmware, we've gotten, we think, the pins to the audio codec, but this audio codec is such an advanced thing with so many different features and capabilities. And we don't know, I don't know exactly which features and capabilities the original teenage engineering device was making use of or not. And so, oh hey 23, wasn't that wasn't 23 hertz what it said something about GP16 was doing? I feel like we saw that 23 hertz in the last session. Ooh, I don't know. Yeah. I wonder if I could give it like PyPDF or one of the other ones it asked for. I wonder if I could give it a better tool to see the PDF rather than trying to reference Linux. I mean, Linux kernel, though, if it does exist there, that would be helpful. Okay, I'm going to run to the restroom, come back, and then we'll pick it back up. We'll give it a few more minutes, though, and then I'll probably wrap it up after that. Like it got a response. Let's go into download another thing. Linux kernel. Thing that occurs to me is the NAU 8821. No, is that a thing we can just... Oh, this might be first party. Nuvoton, I think, is the company? Look like versions, but I don't know for sure. We were in what? K54510. Huh. Okay, one thing that's definitely worth doing is cloning this and giving the Claude session access to it. Going back to Linux. This could potentially be a better path though, using Arduino code. One digital microphone interface, one digital mixer, two high quality DACs and ADCs. So would that be because it's Microphone. Digital microphone because it's I2S, maybe? Is this data sheet? I could put the converted one in the temp DS text. But it never, like, thinks to check there next time. Really? Alright, it's looking like it's gonna write a thing. So I think what I'll do is I'll let it, we'll let it write. Oh, it's waiting for me. Shoot, this is that control thing again where it's not showing me the dialogue. Because I have the control O thing open. We'll let it do this, and either way, I'll probably wrap it up afterwards. Oh, we got something. Stop. Fingerprint clean. Every register latched to intended values. Charge pump is reporting active. General status. Codec is configured so the microphone loops internally to the headphone. And you check the audio, even in silence, or maybe a hiss or a hum. Sure, that was audible. Yeah, that wasn't really audible. It was like a click. It was almost like when a thing connects or disconnects, which is a good sign. However, I will say I wasn't talking. Check, check. Testing, testing. 1, 2. Check, 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 check. That doesn't seem like it's doing anything. Step is self-generated. Okay. I think what I'm going to do is axe this one. It definitely did something, right? Because we were flat this whole time for minutes on end until we got this little blip of right when it started doing its thing, we got this. And this is not a useful sound exactly. It didn't sound like anything other than a blip, but the fact that this happened right when it was doing its stuff makes me think it's on the right track at the very least. I am thinking next time around I give it access to this stuff, and maybe that will help it. And then also I'm thinking we should do the pure tone thing instead of the microphone thing, just because I don't know how the microphone could be interacting with the button side panel paddle thing. Like usually you in teenage engineering firmware, you push that side paddle, which allows you to then start talking through the microphone, and it will send the modified audio out through the headphone jack. But I don't know if having that paddle just rubber banded closed and being in stock MicroPython would somehow cause, I don't know if maybe the microphone's not technically connected or whatever because of the way we have the paddle. So using a pure tone will eliminate the microphone and the paddle from the situation altogether. And I think having this code here might help it along because it has a reference that it can see that's in good formatting and stuff. It doesn't have to just download random Linux kernel firmware stuff, which is helpful, but direct source. And again, I think this looks like it might even just be first party. Like Nuvatron, I think Nuvatron is the company that made it. So I don't know for sure if this is first party, but it looks like there's a chance this is maybe just published by the people who made the chip, in which case it's like as good as it gets for a reference, I think. But I think that's going to do it for today. I'm going to wrap it up here. So thank you everyone for watching. I hope you all do have a wonderful rest of your Saturday, rest of your weekend. I don't think actually that I will be back on Tuesday. I do usually stream on Tuesdays at 10 a.m. Central Time over on the Adafruit channel. But I think I'm going to be taking Tuesday off this week. So I won't be working or streaming. But starting next week, then I should be back there on the Adafruit channels on Tuesday. That's at 10 a.m. Central Time. And then I do usually stream here on my channel on Saturdays, also at 10 a.m. Central Time, although as noted at the top, I did start a bit earlier today. My experience with GPT is that it isn't aware of what it's doing from a larger context until it finishes a task or request. Yeah, that's totally true. I would agree with that. I use Claude a lot more than GPT these days, but in general, I do think the LLMs are... they lack a coherent understanding of the larger picture. They're very much in the weeds, focused on sort of blinders, it feels like to me as well, where they're focused on the one thing they're focused on and they don't necessarily stop to consider the larger picture, or could even possibly be the case they don't have the ability to really perceive the larger picture. I'm not sure one way or another, but yeah, they do get down in their own little world sometimes. So yeah, thanks for watching. I will see you all next time. So long, farewell, and goodbye for now.